this one is one of your references. So to indicate that which combinations do you have, or is your analyte an acid or a base? So you can refer to this table. Okay, and then at the bottom here, if you have a weak species or a strong species, remember to indicate the buffer region. For MS32, this one method will explain to you again. Okay, so let's try question number 2. Continue from where we stopped. For all classes are the same for now, yeah? Okay, are you ready for question number 2?
Ready.
Okay,
Ready.
because madam just give you the questions, therefore you need a new page of paper. There's no table like question number 1. Question number 1 is just a template for you to see step 1, what are we going to do, step 2, what is it, and then until titration curve. All right, so let's begin with this one. So question number 2, given in the questions that we have 25 milliliter 0.25 NaOH, which is titrated with 0.1 molar benzoic acid, C6H5COH. Then you need to sketch the titration curve. So given also in the questions the value of Ka. So this one Ka refer to, we will need to use this one at some point. Okay, so first of all, what is your analyte in this case, in these questions? Is it NaOH or C6H5COH?
NaOH.
NaOH, as the volume's 25 and then is titrated with the titrant. So in this case, benzoic acid is your titrant. And then second step over here, we need to indicate the initial pH. Okay, so since your analyte is a strong base, therefore initial pH will be straightforward. Depends on your strong base. Okay, so madam show you again over here. And AOH concentration will be the same as OH minus, as it have complete dissociation, which is equals to 0.25 molar. So apply your formula POH negative log OH minus, and then do your substitution. What's the value of POH do you get here? Any idea? What is the POH value, the pH value? Just simple calculations, huh?
13.4.
13.4, that is pH or POH?
pH.
Okay, so 13.40. Here will be 0.60. So try practicing your calculator. And then for your third step, what is it? What is the third steps that we have?
Find the pH range.
Find the pH range, yes. So this is at which point? Is it initial, equivalence, or final?
Equivalence point.
Equivalence. Okay, so at equivalence point, remember that we have two things to find. One is the pH range. Is it greater than 7, equals to 7, or less than 7? And another thing is the volume of your titrant. So in this case, we need to write the equations for neutralizations. So we have NaOH. Okay, react with the benzoic acid. And what salt do you producing here? What is the product?
Sodium benzoate plus water.
Sodium benzoate. Very good. C6H5 COONA. This is sodium benzoate salt, and also the water. Water in liquid. So this is a neutralization equation. And then we have see the product of your salt over here. Then the next equations, what we want to do is the complete dissociations of the salt. Okay, so we have CCH5COONA, which complete dissociate to give you the conjugate base COO minus and Na plus. So from here, you can do some interpretation, which ion will undergo hydrolysis. So of course, sodium from a strong base. Okay, this is dissociation from a strong base, which will not undergo hydrolysis. All right. Whereas your conjugate base CCH5COO minus is from the weak acid. Okay, this is from the weak acid. Therefore, the conjugate base will undergo hydrolysis. Therefore, you need to come up with the equations to show to show the hydrolysis of this conjugate base. Okay, so we have C6H5COO minus react with water. What is the arrow? Is it single directions or reversible? One way
Reverse.
to reverse. Hydrolysis, I remember, reversible. To give you CCH5, COOH. Since the conjugate base will take the proton, then the H2O remains with OH minus. Remember that why we want to do the hydrolysis, as we want to see which ion will be produced in this hydrolysis process. So if you got OH minus, indicate that the pH value should be greater than 7. Okay, so this is the pH range at equivalence point, or pH is more than 7. All right, and the second part in your step 3 is to find the volume of our titrant. So in this case, titrant is our weak acid. Okay, so we apply the formula. Tell me about the concentrations for the weak acid, or okay, hold on a second. So MAVA and BVB. How about the concentrations for weak acid? Your titrant.
0.1 molar.
0.1 molar VA. Okay, how about your concentrations for the base?
0.25.
0.25. The rest of it, please follow, yeah? Okay, so the volume given in this case is 25, the one in your conical flask. And then the ratios over here is 1 to 1. So in this case, volume of your weak acid. So here I change the abbreviations to the terms. Volume of the titrant benzoic acid equals to 62. Hold on. Okay, equals to 62.5 milliliter. If you want to use stoichiometry, that's fine also. Now you will get back the same value, 62.5. So at this step number 3, at equivalence point, you find the pH range. Okay, and then you find the volume of titrant. So both informations, you got it already. Okay, until this part, can you all follow? Is everyone alright? Or am I going too fast?
Okay.
Cepat sangat tak? Boleh ikut do I need to stop a while? Tak perlu.
Tak.
Okay. So next one is our step 4. What do we want to find after equivalence point?
Final pH.
Final, which depends on
Titrant.
titrant. So in this case, our titrant is a weak acid, a weak species. Okay, so we try to recall back the ways for you to calculate pH value for weak acid. So first of all, you need to have this partial dissociation of your weak acid. Partial dissociation reversible to give you CCH5, COO minus, and H plus. So now we want to do an ice table. An ice table. So concentration initial, the change in concentration, and the equilibrium concentration. So given in the questions here, the weak acid, benzoic acid, you have 0.1 molar. So initially, there is no conjugate base, there is no H plus. Okay, but then it will slightly dissociate to give you minus x, x, plus x, and plus x for the product. So final or equilibrium concentrations, you just add it up together. And what is the next thing we want to do after istable?
Ka expression.
Very good, Ka expression. So this one is step by step, of course. But objective questions, if you know already, you can straight away solve your quadratic equation. Okay, so we have the product on the top, the weak acid on the bottom. And then we just substitute the values in here. X multiply x give you x squared. And then 0.1 minus x, the weak acid. Value of K in the questions, we got 6.5, 10 to the power of negative 5. So substitute the value in your Ka. And then you need to solve your quadratic equation. Okay, so solving quadratic equations, again, you need to practice this one. So madam give you the value straight away, just to double check whether you got this values x or not. Okay, so we take the value that will give you only positive concentration. So 2.52, 10 to the power of negative 3 molar. All right, and then we look at this thing. In order to find your pH value, this X is actually the concentrations of your H plus. Therefore, we can apply the formula pH equals to negative log H plus. And then substitute the value of X that you got over here. This one is the same value. So substitution gives the value of pH, which is equals to, you find it. Mereka dah bagi value untuk X kan, awak carikan untuk pH pula.
$2.6.
2.6. The rest of you agree?
Yes.
Boleh ya? Okay, 2.6. So if you compare to the example that madam showed you just now, if a strong acid will give you roughly about 1 point something, 0 point something for the pH value. But if you got a weak acid, the pH value will increase slightly. You got a slightly higher pH value for weak acid, but still less than 7. Okay, so now we have gathered the information: initial pH, equivalence pH, volume at equivalent, and the final pH. Now the final step is to sketch your titration curve. To know about the patterns lah. Okay, so step 5 over here. Kejap ya. Okay, step 5. What is your y-axis? Your y-axis is
pH.
pH.
pH. How about your x-axis? Volume of? Volume of what? What should I write over here?
CCH5COOH.
Very good. The titrate, but be specific. So sometimes in the objective questions, you need to pay attention to the x-axis. See what is the formula given in this case. All right. So this is volume of titrant. And in this question, titrant is your benzoic acid. So your initial pH just now you calculated is 13.4. Okay, 13.40. And then for your pH at equivalence is more than 7. Okay, so we roughly pointed over here. So pH is more than 7. So this is at equivalence point. How about the volume? How about the volume at equivalent? 60?
0.5.
62.5. Remember at the center point here or equivalence point, there's 2 things that you need to label. Okay, pH range and the volume of titrant. And then the final pH value is 2.6. Okay, and then you need to sketch the curve. So going from the strong base, when you added your acid, you're creating the salt. Make sure the portion is steep enough. Show the vertical portion, your steep portion. Here is your pH jump. Okay, the change in pH, whereby the indicator will change color at the endpoint. All right, so this is your diagram. And recall that for MS32 as well, this is an extract method didn't mention in the yesterday class. So if you have the combinations between a weak species and a strong species, there will be a region which we call as the buffer region. Okay, so this buffer region is actually what we learned in 7.1, the buffer solution. So you need to make sure you understand how to look at this buffer region. So madam, go through again now with all of you. So in these questions, starting with a strong base. So at this point, okay, at this point, we only have the strong base. So when you gradually added your weak acid at this region, you only contain the strong base, acid strong base, and the salt. As before equivalence point, the added acid will be completely neutralized. Okay, the added titrate will be completely neutralized. So that means before equivalence point, what do you have inside the mixture is just the excess strong base. Okay, and the salt. And of course, there is water. But then when you reach the end, the equivalence point at this one, this X marks, at equivalence point, all the acid and all the base completely react. So the remain solution inside the conical flask is just salt and water. So at this point, we only have the salt and water. So when I continue added the titrant, at this point, continue added titrant, added titrant, added titrant. So the remain solution inside conical flask now containing salt, water, and titrant. So the titrant now is weak acid. Therefore, we can indicate that this region, the region after equivalence point, is the buffer region. Okay, why buffer region? As it's containing salt and the weak acid. The definitions of acidic buffer or basic buffer, what is inside the buffer solution. Okay, so every time when you sketch the curve or maybe objective questions, you need to able to indicate which one is the buffer region. Okay, by looking at the container, what is the content in the solutions now. So is there any question for the titration curve here in questions 2? So in your final, like say the final curve, of course you doesn't have this thing now. You only need to label buffer region. You don't have to specify what is the content. So is everyone all right?
Alright.
Yes, madam.
Okay. So we try one more questions, which is your question number 3. Question number 3. Still the combinations between a weak species and a strong species. Okay, so question number 3, let me know which one is your analyte. Tell me about your analyte.
NH3.
NH3. So NH3 is titrated against, or NH3 has the volume 25 milliliter, which is fixed. And of course, titrant is HCl. So you have a weak base. Okay, you have a strong acid. Just now is strong base and weak acid. Now terbalik. So analyte is the solutions containing in your conical flask now. So how am I going to calculate the initial pH? Macam mana nak kira initial pH? How am I going to do this?
Ice table.
Ice table. Oh, since NH3 is a weak base, you need to figure out the pH value from the Kb, from the ice table, from the quadratic equation. Okay, so NH3, when it dissociates into water, it will give you the conjugate acid and the OH minus. So we have the initial concentration, change in concentration, and the equilibrium concentration. So given in the questions NH3, the concentration is 0.1. So exactly the same as the value just now. So minus X, and then over here, you have plus X. Okay, and then similarly, we have the Kb expression. So Kb, so we will be the NH4 concentration times with OH minus divide by concentrations of NH3. So in this case, still the same. We're having the value here. Then substitute the value of Kb and then solve it quadratic equations to get the value of X. Okay, sama jugalah madam bagi dulu awak punya value X, but then you need to practice you need to practice your quadratic equation. Okay, so the values of X over here we have 1.33 times 10 to the power of negative 3. So which is also the same as the concentrations of your OH minus. So if you're curious where is it finding for the OH minus, then you look back at your ice table. Okay, and then try to calculate the pH value for me. Don't forget, pOH is what we are looking at. Let me know what is the pH value in these questions.
Eleven point 12.
11.12 for the pH. The rest of you agree? Jangan tunggu jawapan saja. Bila awak ada dah sempat ni, tekan calculator, check 11.12. Okay, so this is your initial pH of weak acid. Yes, Sue?
I don't know, the same answer. I get the
I
same
get the
answer.
same answer. Okay, thank you very much. So initial pH NH3, you got a slightly lower pH value since it is the weak species. Okay, and then the third part, the third step, we want to find the pH at equivalence point. Okay. Okay, so equivalence point. So again, you have three equations at this point. So the first one is the neutralization equation. Weak base, strong acid to give you.
NH4Cl.
Very good. So NH4Cl. Okay, the salt. If don't have H2O as the product, don't worry. The aqueous itself indicate there is water inside. So NH4Cl. So this is the salt produced. Then we want to do the dissociation of the salt. So NH4Cl dissociate completely to give you NH4 plus and Cl minus. So which of the ion produced here will undergo hydrolysis?
NH4 plus.
NH4 plus Cl minus
Does not hydrolyze.
does not hydrolyze as it produced from the strong acid. So in this case, your equation for hydrolysis. So this one is just practice back whatever you learned previously. Okay, so react with water in equilibrium because hydrolysis to give you NH3 and H3O plus. Okay, NH3 and H3O plus. Make sure the equation is balanced. Then you can see what is the ion that produced here. Since you have the H3O plus, the hydrogen ion, therefore we know that the pH is less than 7 at equivalence point. All right, and the next thing we want to find at equivalence point is the volume of titrant. So in this case, titrant is your strong acid. Okay, titrant is the strong acid. Therefore, we apply the formula. Okay, you do it together with madams, yeah? The concentrations, acid we got 0.1. Again, volume is the unknown. And then concentrations for the base 0.1 as well, volume 25. So if you look, it's quite similar. Therefore, the volume of your acid is the same, 25. Okay, until this part, can everyone follow? Am I going too fast? Oh, you're just fine.
Fine.
All right, yeah? Okay. So equivalence point, pH range, volume titrant, got it. And then we proceed to the step 4, final pH. Which again it depends on titrant. So titrant, HCl, strong acid, straightforward. So in this case, when you done calculations, the pH value will be equals to 1.0. Because concentration is 0.1. So when you do negative log 0.1, it gives you 1.0. Okay, so for this part, you calculate on your own. So initial pH 11.12, equivalence pH less than 7. Volume, we got it already, 25, and the final pH 1.0. So gather everything, we need to plot your titration curve. All right, so pH. Okay, again, what is the x-axis? Volume of? What should I write over here? HCl. Pay attention to the specific formula down at the x-axis. Okay, so from there you can indicate, oh, that is the titrant actually. All right, so our initial pH, okay, we have 11.12. Equivalence pH, we have less than 7. And the volume, we have 25 milliliter. Final pH, we have 1.0. So sketch a curve. You have something look like this. Okay? It just roughly, as long as you have already indicated the value of pH, you just draw the shape of the curve. Is it from upwards towards downwards or downwards towards upwards? So it depends which one is analyte and titrant. Okay, and then what is your next thing you need to do? What is the final things we need to label?
Buffer region.
Okay, is it before equivalence point or after equivalence point? How do you think?
Before.
Before. Okay, before equivalence point. Since initially we have weak base. So when you add strong acid, you're creating salt. So now the solutions before the equivalence point containing the weak base and the salt. Therefore, you need to label here. This is our buffer region. Acids containing the weak base and the salt. If it's after the equivalence point, the solutions only containing the salt and a strong acid. So it is not a buffer. So be clear which one is the buffer region. So this will be your titration curve. between a weak species and a strong species. Okay, so any questions until this point for questions number 3? Kalau madam terlalu cepat, siapa yang tak boleh ikut boleh bagi tahu
Madam,
Yes.
nak tanya lagi sekali yang kenapa buffer region tu dekat situ?
Okay, kenapa buffer region dekat situ? Now madam change another color to show you this one. Okay, so siapa yang tanya? Bakis Okay, Bakis over here you see initially, okay, it refer to the content inside our conical flask, isn't it? So this is our initial pH, which depends on the weak base. Untuk soalan ini lah, dia adalah weak base. Okay, so when you added the strong acid from time to time, tempat yang madam lukis dekat sini, kita tambah strong acid. So now when you added strong acid, the amount of strong acid added is limited. So whatever added the strong acid before equivalence point will be completely neutralized by the base. So maksudnya semua HCl yang kita tambah sebelum equivalence point ini, dia akan hilang terus. Weak base dia akan neutralizekan dia. Okay, so after the neutralization reaction, no more HCl, but you still containing the weak base. So pada point sini, kita masih contain lagi weak base. We still got the weak base. And of course, neutralization is complete reaction. So acid dengan base dia sudah react, dia akan hasilkan salt. So in the content over here, containing weak base, ada excess lagi, dan dia ada juga dia punya product salt. Do you get me?
Yes, madam.
Okay, so until this point, just now we say equivalence point is when all the acid react with all the base. So maksudnya acid dengan base sudah hilang semua. Nothing's left for acid and base. So at this point, equivalence point, whatever content at this point is just the salt and water. Just now this one is your weak base lah. So at equivalence point, you're only containing salt and water. So imagine if after this point, I keep on adding my titrate. Saya masih tambah lagi titrate saya. So maksudnya saya ada extra HCl. Just now I say until this point, no more weak base. Sudah tak ada base yang initially placed in your conical flask. But we adding more titrate. That means it will having extra HCl. So kalau kita tengok pada region ini, apa yang ada dalam solution ini adalah HCl dengan salt dengan water. So you go back to the definitions of buffer. Strong acid, salt will not be a buffer. Buffer mesti salah satu adalah weak species, weak acid ataupun weak base dengan garam dia. Salt with the conjugate pair, conjugate acid ke conjugate base, doesn't matter. Okay, so this will not be your buffer region lah. Okay, yang ini tak akan jadi buffer region sebab dia bukan, dia punya content bukan buffer. Do you get what I mean?
Yes, madam. Thank you.
Okay, so every time you need to check and then you try to tell yourself story. Okay, sekarang ni dalam container ada apa? Kalau hanya strong species dengan salt, dia bukan buffer. Kalau dia ialah weak species dengan garam dia, okay, yes, it will be a buffer. Then I need to label it. Okay, so tips yang madam bagi dekat sini tadi, madam ada bagi satu PDF file kan dalam semua Telegram group. For MS32, this one we haven't finished yesterday, right? So you just add on over here. Where is your buffer region? Okay, madam using just now the two questions, question 2 and 3 to explain about buffer region. So you just add on into the table. Okay, so you can refer back to your PDF file. Where is the buffer region? Try to explain to yourself once again. What is it buffer? Kenapa buffer dia dekat sini, dia bukan dekat sini? Kenapa kita bila terbalikkan dia, analyte jadi weak base, strong acid titrant, ini pula jadi buffer region. So you need to explain this one to yourself again as a revision. Okay, kalau ada sesiapa yang tak faham lagi boleh tanya dalam kita punya hybrid kelas nanti lah. Okay. So, Madam want you to look at the exercises. Okay. The exercise 1 for titration. Okay, so over here you have 4 questions. Question 1, 2, 3, 4. 1, 3, 4 you can practice on your own. Madam want everyone to look at questions number 2. Soalan ini ada 5 part. Part A, calculate the pH before titration. How about the pH value after adding 10 mL of a weak base? Soalan kedua ni Madam explain, and then you can try to apply the concept to questions 1. Is that alright? Boleh ke semua?
Okay.
Boleh, madam.
Alright. So let's look at questions number 2. Okay, in these questions, let's look at the informations we have here. In an experiment, 40 milliliter of HCl is titrated with 0.2 molar NH3. Okay, given the questions also, you have the Kb for a weak base. So this is a combination between a strong acid and weak base. Okay. So from the first sentence over here, which one is your titrant?
NH3.
Okay, NH3 is the titrant, yeah? So we write over here first, and then HCl will be analyte. Maybe you have one question, Madam, bukan cakap 25 milliliter adalah analyte ke? Okay, dia tak semestinya 25. You need to make sure it is constant. How are we going to check? Let's look at the questions first. Okay, so the questions down below here, we have A, calculate the pH of HCl before titration. So the clue is already given. Before titration, the content inside conical flask is just the analyte. So analyte will be your HCl. Okay, and then throughout the questions, you doesn't see any changes in volume for the HCl. So confirm again, HCl is your analyte. Okay, and then for part B, calculate the pH of the solutions after adding 10 milliliter of NH3. So we want to calculate one by one. Okay, and then predict pH value at equivalence point, similar like the question 1 to 3 just now. And D, calculate the pH after adding 55 milliliter of NH3. Lastly, to sketch your titration curve. So compared to the example questions, now we just adding extra questions for B and D. Okay, B and D. So let's look at this one together. Okay, tell Madam the first part. Okay, part A, what is the pH value? Jawab banyak kali kan, 0.1 HCl, strong
Satu.
acid. 1, very good. Tapi kena tunjuk calculation. So calculation sama macam tadi, so Madam tak tunjuk lah ya. Mungkin ada yang keliru. Madam kenapa 0.1? So you need to do it all over again. Concentration H plus, pH equals to negative log concentration H plus to find the pH value. Okay, so Madam bagi jawapan dekat sini 1.0. Then for part B, pH of the solutions after adding 10 milliliter of NH3. So volume is only 10 milliliter. So you need to write out the neutralization equation. So we have HCl aqueous. We have NH3, the weak base. Neutralization is complete reactions to give you NH4Cl. Okay. So recall back when we're doing the buffer. Okay, when we're doing the buffer, let me tell you something. If there is changes in volume, what happens to your ice table?
Use mole.
Use number of mole. That is the quickest way lah. Okay, because if you look at this one, initial volume is 40. So after adding NH3, the total volume change. Okay, the total volume change. That means you need to figure out the initial number of mole, final number of mole, and then the final concentration before calculating pH value. Okay, so let's do this one. Initial mole, change in mole, and final number of mole. Then we add one more row, final concentration. Final concentration. Okay. So we calculate straight away into your ice table. For HCl, what is the number of mole? HCl, what is your number of mole? 0.1 times 0.04, which give you?
0.004.
0.004. Okay, so that is getting from the informations provided. Okay, NH3 concentration is given 0.2. Okay, volume is given 10 milliliters, 0.01, which give you 0.002. Okay, so initially number of moles for the salt, nothing, and then nothing. So now we are doing the initial one. Okay, so between HCl and NH3, which one is your limiting reactant?
NH3.
NH3. So we will minus or neutralize all the NH3 added. So now the NH3 remains nothing in your solution. Remains nothing with your equation. So madam, add for the salt over here lah. So 0.002 over here. Okay, and then the remaining of your HCl is 0.002. So now in your solution, it contains HCl and the salt. Okay, containing HCl and the salt. So the pH value depends on which one? Where is your pH value depends on if you have a strong species? Any idea? Now, even though you have the salt over here, but now the content inside your conical flask is just the strong acid HCl, okay, the salt NH4Cl and water. But then we know that nothing related to buffer, isn't it? This is not a buffer. So actually, I can just leave this one blank. Kalau awak takut confused, ini jangan tulis sebab dia bukan buffer. So the salt actually at here doesn't have any function. So we just calculate the concentrations of our HCl. pH value will depend on the strong species. So total volume 40 plus 10 give you 50 milliliter, which we got 0.05 liter. So do your calculation straight away inside the ice table. 0.002 divide by 0.05. And the concentration HCl, you got it, is
0.04.
0.04. Okay, so again, madam, say again, for this column, okay, you want to fill in can, you don't want to fill in also can, because it doesn't have any effect towards the pH value. Reason, because now you're having a strong species. pH value will depend only on the HCl. Okay, so this one fill in can, you want to leave it blank also, doesn't matter. Then we continue with the pH value. So pH equals to negative log concentration H plus. And since we know the HCl has the concentration similar to H plus, 0.04 molar, then you need to apply into your equation. You can also jot down over here lah, pH value depends on HCl only. Okay, since HCl is a strong acid. Okay, what is the pH value that you have got over here?
1.4.
1.40. The rest of it agree?
Agree.
Yeah.
Agree.
Yes.
All right, so this is the pH when you just add a little bit of NH3. Okay, so part C, what do you want to do? Predict pH of at equilibrium point. So just now we have already write our equation. You got the salt NH4Cl. Okay, so NH4Cl, when it dissociate, it will give you NH4 plus and Cl minus. So give me the pH value at equivalence point. What is it? So sama juga macam soalan tadi lah. Bila dia react dengan water, hydrolysis will give you H3O plus. So what is the pH value? Okay, dua equation yang Madam tulis ini sama dengan soalan 3 tadi. NH4 plus, which dissociate from the salt, undergo hydrolysis to produce H3O plus. So what will be the pH?
Less than 7.
Less than.
Less than 7. pH less than 7 at equivalent. Okay. So remember that even though the question tanya tak volume tak ada. Okay. Even though the questions didn't ask the volume at equivalence point, but because you want to sketch the titration curve, you need to calculate it. Okay, perlu jugalah kira. So kita kira sekali dekat part C. Okay, so again formula A over B, concentrations of the acid 0.1, volume of the acid 40. Yang bawah, Medan nak isi apa? What do I need to fill in at the bottom?
.2 volume.
0.2 volume of your base. So volume of the base is NH3. So in this case, you get 20 milliliter. Okay? So part C adalah untuk equivalence. So there is a range. Okay, there is a volume of titrate. Okay, so we proceed to part D. Is that all right?
Okay.
Madam,
Yeah.
don't we need to explain like the NH4 plus will undergo hydrolysis and then the Cl plus will not undergo hydrolysis, the ion?
The explanation you mean?
Yeah.
Actually don't need. If you draw the equations already, then you can identify, okay, NH4 plus will undergo, then you straight away draw the hydrolysis equation. That will be fine.
Oh,
Because
all right.
now we just want to obtain the informations for us to sketch the curve.
Oh, okay.
Unless the questions ask you to explain why the salt is an acidic salt, then that will be your explanation.
Okay, understand.
All right, and then we proceed to part D. Soalan D tanya apa ya? pH of solutions after adding 55 milliliter of NH3. So now it's adding extra titrant. So sama jugalah kita akan pakai balik ice table tadi. Okay, so tak apalah, Madam lukis sekali lagi. Okay, so HCl. Okay, react with your NH3. to give you NH4Cl. Okay, so now again in your ice table, we use number of moles since then there is changes in the total volume. Total volume berubah kan? Okay, so what is your HCl number of mole just now? 0.0? Number of mole is the same, right, for the whole questions. Number of mole HCl. 0.1 times 0.04 give you 0.004 mole. Ada sesiapa yang tak faham tak macam mana nak dapat 0.004? Faham eh?
Faham.
Make sure you know. Jangan copy tapi tahu awak tak tahu apa value yang ada tulis ni. 0.004 datang daripada tadi. Tadi awak sudah kira kan dekat sini. So you don't have to show it again. Because number of mole HCl is fixed already. But then the number of mole for NH3 is different. Concentration 0.2 times with the volume added, which is 55 milliliter, so 0.055. Tolong kirakan mole untuk NH3.
0.011.
Very good, thank you. 0.011 for that. So initially there's still no salt. Okay, then we have to identify your limiting reactant in this case, which is
HCl.
HCl. Well done. So we will completely reacted all the HCl. Okay, so same thing for NH3 minus 0.04. For the product side, we just add it plus 0.004. So nothing left for the HCl now. All the HCl is completely reacted. But you have this one, 0.007 mole remains for the NH3. Okay, so what is the total volume now? 40 plus 55 give you 95 milliliter. So we convert it ready for the calculation. So to calculate your final concentration, 0.007 divided by 0.095 to give you 0.0737. Correct me if I'm wrong, because I don't want to rush for the time. Okay, so 0.037 is the concentration for NH3, or after all hydrochloric acid is neutralized. And then for this case, we need to calculate the concentration for the salt, 0.095 to give you 0.0421. Okay, Madam, kenapa tadi saya tak perlu kira garam, sekarang perlu pula? Tadi ada strong species, so tak perlu. Sekarang, apa yang awak ada is just the weak species, weak base. Okay, and the salt together will give you the buffer. Okay, will give you the buffer. So, your calculations for pH depends on the equations for buffer equation. Dia bukan lagi pH sama dengan negative log concentration H+. Tak. Dia tengok pada awak punya mixture, you punya content dalam solution. So over here you can indicate, why is it taking both value here? Because this is a basic, since it's weak as it's a weak base, so basic buffer. Okay, so kita kira dulu ya. Okay, so we have the basic buffer, so POH equals to negative log KB. And the salt on the top, we have NH4Cl. Okay, weak base at the bottom, NH3. So in this case, apply your KB value, 1.8, 10 to the power negative 5. And then log concentration on the top, 0.0421 over the base, 0.0737. Okay, So in this case, the pOH value give you 4.50, the pH give you 9.50. Okay, so this one is for part D. So what Madam say is you need to make sure your 7.1, you understand it. So later on, it will combine, okay, into the titration process. So when you realize there is weak acid or weak base with the salt containing their conjugate pair, that will be a buffer solution. So calculation pH depends on Henderson-Hansberg equation. Okay, so please take note on part 5 here. pH value depends on buffer solution. So for the last one, sketching titration curve, I leave it to you. You sketch it on your own. Later on, you can check the answer. Okay, so far, any questions until this part?
Madam, so for the sketching part, we need to calculate the final pH, is it?
Final pH, you don't have to, because this one have already give you the extra titrate. So you just slightly more than that, that should be fine. You more than this one, say this one is 55 milliliters, right? pH is 9.50. Okay, so your final curve where you want to stop, you just raise it high up a little bit more than this 9.5, then should be all right. So later, Madam, show you the answer.
Oh, all right.
Okay. So the attendance matter forward into your respective Telegram group, yeah? I think you have the next class. Are you? Ada kelas lagi tak?
Ada.
Madam stop kat sini dulu ya. Alright. So that's all for the lesson now. Thank you, class.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you,
Thank you, madam.
madam. Thank you, madam.
Thank you, madam.
Madam.
Thank you, madam.